I'm going to do the problems for 7-6 starting with number 18, and I'm going to have separate videos for each problem so that it's easier for you to pick the problem that you would like to get review on. I'm going to try to be as detailed as possible to kind of help you with how you model these functions. Remember, we are trying to come up with a function that looks something similar to this, and I wrote f of x is equal to a, which is my amplitude. Now, it's either going to be cosine or sine. We're not quite too sure. It's a sinusoidal function. It doesn't mean that that's going to be a sine function or anything like that. It just means that it's going to be sine or cosine. We're not quite too sure which one. If I'm going to start at the middle, like right here, then it's going to be a sine function. But if I'm going to start at the max or the min, then it's going to be a cosine function. And then I'm going to be taking the cosine or sine of bx minus c plus d. So there's a couple of things that we need to find. We need to find A, B, C, and D based on the information that we've been given. So the problem says that outside temperatures over the course of the day can be modeled as a sinusoidal function. And suppose that the high temperature of 84 degrees occurs at 6 p.m. So right about here, I have a max. And the average temperature for the day is 70. So this is my midline because I've been told that my average temperature is 70, my max is 84. So from there, I actually have a couple of pieces of information. I have the amplitude, which is the difference between the midline and the max and or min. So 84 minus my midline, which is 70, is 14. I also have the offset, which is my midline exactly, which is 70. So my D value is 70. My B value is the period, and the period is based on what my input is. Remember, cosine or sine functions are cyclic. They have a period of 2 pi. And so we know that the equation to get this value B, or at least this value B, is defined by 2 pi over B is equal to my period. It is my period that I'm looking for. Well, I know exactly what my period is. My period is between 12 a.m. and 12 p.m. So that's 24 hours. So we know that 2 pi over B is going to be equal to 24. If I were to give you any sinusoidal function, that my period would create 24, and we'll show you what that means when I get it. So this is going to be, when I simplify it, this is going to be b over pi over 2, or sorry, pi over 12. So pi over 12 is my b value. And remember, if you take that value that's here, this pi over 12, and you divided it, and you said 2 pi over 12, this would equal 24. So that's how we know that this function is the function that we need. We know that whatever value b is, if we take 2 pi and divide it by that value, we would get the value 24. And that's what we know we need as a period. We might not know what the period is, but we have the value b, so we can get the period by dividing the value b into 2 pi. Or if we already know the period, then we can just solve for b, whatever's supposed to go here. So now we know what b is. B is pi over 12. And we also know what c is, which is an interesting thing to show you. Because if I were to solve for c, I could plug in values that I know. For example, I do know that my input 6 p.m. would result in a temperature of 84 degrees. So I can plug in 18 for x and 84 for f of x and solve for c. But there is a much more interesting way to write this, and I'm going to show you what that looks like by just simply writing out the equation down here. We know that f of x is equal to the amplitude 14, and we know that this is going to be a cosine function. How do I know that? I know that because I'm going to be starting my graph from right here. And when I start my graph, I'm going to draw a single period. And by starting here, this also means that I have offset my starting point by 18. So the fact that I'm starting up here on a max to draw my cosine graph and to draw by one period, starting up here at the max, that means that it's a cosine function, and it's a positive cosine function. I'm starting at the max. I know what my period is. It's pi over 12 times x, so x times pi over 12. And now I need to apply my phase shift, and I can do it in a very simple way. In fact, without writing this x, I'm going to get rid of that for a second because I was not supposed to write that. I'm going to write pi over 12 times x minus 18. And then I'm going to add my midline. This is a very clean way to represent the period, which is b here, and to represent the phase shift as a binomial of x minus whatever my phase shift value is in a number of units. Because if I were to multiply this out, it would give me my c value. In fact, if I were to do this up here, and I'll just erase it later, that's going to be x pi over 11 minus 18 pi over 12. So we would know that the value for my c is going to be 18 pi over 12 if I plugged in, let's see, this is a temperature at 6 p.m., so that would be 18 for my x value and 84 for my output value. That my c value would then return as 18 pi over 12. But we can actually write it in this way. We can write it with the b value, pi over 12, and this is my offset, x minus the number of units that I'm offset. So I now have my function. And now I can use this to answer certain questions. For example, I was asked, what is the temperature going to be at 7 a.m.? There is a cosine function. I'm just going to be drawing something on average. I don't know what this thing actually looks like, but it's going to be something, it's going to come down to here, and it's going to come back up to here, and eventually over here at 6 p.m., it's going to be back up to 84. So we're looking for this point right here. And I know that this graph is not 100% correct because I'm pretty sure that that might not be the lowest point of the graph. But, it's a good average. It's a good estimate. But I'm looking for this exact point. I'm looking for this y value. And I'm going to be plugging in the x value 7 a.m. Well, what's that value? Well, if x is 0 at this point, this is 1, 2, 3, 4, 5, 6, 7. So f of 7 is equal to 14 times cosine pi over 12, and that's going to be 7 minus 18 plus 70. If I were to write some more down, f of 7 is equal to 14 times cosine. Let's simplify this. That's negative 11, so this is going to be negative 11 pi over 12 plus 70. Cosine is an even function, so if I apply a negative radian, I'm going to get a positive value. So this can actually be adjusted to a positive value. Now I'm going to take cosine of 11 pi over 12. So I'm going to take 11, multiply it by pi, divide by 12, and take the cosine value of that. That's negative 0.96. I'm going to multiply that by 14, and I'm going to add 70. And I get 56.447. So let's write that down. F of 7 is 56.4, is it 447, 477, 477. There we go, 477. And if we were to round to the nearest degree, it would be 56 degrees Fahrenheit. So that's the answer to question number 18.